Nuking stuff in movies seems pretty cool. Here on Earth these explosions are very disastrous, but due to virtue of atmosphere, the ball of fire doesn't spread away for a long distance. But what if there isn't any atmosphere? What if we nuke in space?
Before exploring the answer, we must know about nuclear explosion. As we all know, atom is made up of three fundamental particles: protons, neutrons and electrons. In nuclear explosion, the isotopes uranium-235 and plutonium-239 were selected by the atomic scientists because they readily undergo fission. Fission occurs when a neutron strikes the nucleus of either isotope, splitting the nucleus into fragments and releasing a tremendous amount of energy. The fission process becomes self-sustaining as neutrons produced by the splitting of atoms strike nearby nuclei and produce more fission. This is known as a chain reaction and is what causes an atomic explosion. Now you have the whole control. To trigger the chain reaction, just double tap here in 3, 2, 1. Boom. Actually not a boom. Because space don't have any medium to propagate the sound waves. Since there is no atmosphere in space, there is no iconic mushroom cloud, nor a blast wave, which is where most of the damage of a nuclear bomb comes from on Earth. Instead, there will be an intense outpouring of not only heat and light, but high-intensity radiation in the form of gamma rays and X-rays, with no atmosphere to interrupt their path. Visually, the blast will be roughly spherical, and the wave of radiation and light will expand to light up the sky. On the surface of the planet, vivid auroras of light would be seen for thousands of miles within minutes of the blast, because the charged particles from the blast would immediately begin interacting with Earth's magnetic field. Those ribbons of light and charged particle streams would continue to be seen for hours or even days after the blast. In a nuclear blast, there is also quite a bit of debris, which would burn up in the Earth's upper atmosphere, and heavy ions would also be absorbed by the atmospheric molecules of the planet. Perhaps even more worrying than the huge amount of radiation being dropped into Earth's atmosphere is the detonation's impact on electromagnetic signals in a massive area beneath the blast. Essentially, those highly charged, rapidly moving electrons will create a small and incredibly powerful magnetic field, also called an EMP, electromagnetic pulse. It will blown out streetlights, disruptions in radar and navigation systems, and a complete shutdown of electronic communication. There were only a handful of high-altitude nuclear detonation tests in the 1950s and 1960s, but in total, more than 2,000 nuclear detonations were conducted on Earth between 1945 and 1998. Clearly, whether they happen on Earth or in space, nuclear detonations are never good news.
That's it for now. I hope you learned something new today. To join this journey, explore the subscribe button and hit it. Let's explore all at one spot. Thank you.